Okay, everyone, thank you for joining us for the Skill Summer Seminar. This time we have something slightly different. We're going to talk about leaning into probabilistic decision making. I want to remind everyone this is a seminar, not a webinar, so feel free to turn on your camera, unmute yourself, ask questions. We would like to make Pat, Mo, and Amber uncomfortable and on their feet. So please ask any question when you have it. And with that, we're going to go straight to our. So Pat, take it away.
We're excited to nerd out a bit with everyone, talk about probabilistic decision making, and all the wonderful things that come with it. So before we dive into it, just a little bit of context on the team here. My name's Pat. I'm one of the co-founders of Abstract, and we essentially started this out of research back before it was, sort of called large language models, really before LLMs were invented. We were using these natural language models to abstract or make summaries of laws and codes back in 2019. Long story made short, we've worked with over 200 lobbying firms, trade associations, nonprofits, and then we've expanded to service large AmLaw 200 firms and in-house legal over the last 2 years, also venture-backed. So we've definitely been working at the intersection of sort of public policy and legal for the last 6 years here. So I'm one of the co-founders, and then I'll hand it over to Amber and Mo for quick intros on their end.
So I'm Amber. I'm the head of data science at Abstract, and I'm based out of our New York office.
And my name is Mohammed Mo, one of the 3 co-founders of Abstract, also based in the New York office.
Before we talk about probabilistic AI and sort of what that means, a little bit of background, quick background on Abstract and sort of, why we're talking about this. So we essentially sit in what we call the proactive quadrant of the legal tech market. So what we do is we proactively identify changes in regulatory agencies, legislative bodies, and courts that may impact clients. And so we are scanning changes across all these governments and then using the reasoning capability of AI to figure out how it may impact a client. For example, if a tariff comes out from yet another executive order, Abstract's able to pick up that tariff announcement and then figure out how it's going to impact which client and how. So that's sort of our background in terms of how we're using AI to make sense of all this data. But enough of us, let's talk about probabilistic AI and what that means. So it's, in my opinion, sort of a buzzword at this point. So let me hand it over to Amber to explain a little bit more about what this actually means.
Thank you. So there's a lot of things that are called AI. Pretty much anything that has some sort of automation that can do what a human do is often called AI. But probabilistic AI is distinguished by its ability to consider the likelihood of multiple outcomes and make predictions or decisions based on those probabilities. And this is in opposed to something that is deterministic, which only has one single answer and is unaware of other potential outcomes or how they might suit a situation. Right. Probabilistic decision-making can sound kind of abstract, but it's something that we do every day. Whether it's deciding what movie we want to watch or in negotiations, we might consider multiple outcomes and measure them against the data of our specific situation. Even though we're not thinking about things in terms of ones and zeros, we are asking questions about the options we have and our previous knowledge on the subject in order to make the best choice for our goals. So, for example, we might ask the probability of a final agreement in a negotiation if we make a certain concession. A well-trained AI model is like an experienced negotiator who has seen a lot of negotiations, a lot of clients, and knows the nuances of how certain methods would impact the likelihood of success. By entertaining multiple possible outcomes and our judgments of their likelihood, we gain more depth in our decision-making and creativity in our problem solving because we are able to make decisions in situations where a certain outcome is not always a guarantee. This is what AI and machine learning is seeking to recreate in a technical way. So we can compare the training data of the model to our own life experience and learnings, the model to our own minds, and the outputs to our decisions. let's give an example, because there's a lot of different kinds of probabilistic AI as well. LLMs, large language models, are a really high profile form of probabilistic AI, but it's not the only kind, and it's not the only or best solution for every problem. LLMs are trained on language data, so they're optimized to create human-like thought and language. And so they're great for things like drafting letters or summarizing large amounts of text, or things like that. But they're not necessarily trained on how specific features like air pressure or temperature relate to whether or not it's going to rain. There are classifier models that are from machine learning or deep learning that are designed specifically to predict the likelihood of one or two outputs. And those are optimal for this kind of prediction when given numerical data. And that is what weather forecasters would use. So, LLMs are not the only form of probabilistic AI, and there are lots of different types depending on what the task you're trying to accomplish is. So, to get a little bit more into the technology that's underlying this AI, neural networks are one family of AI that underlies a lot of these things. But it can be applied to a lot of different questions, and it has many different forms. They're inspired by biological neurons that activate each other. And when given a set of raw inputs, it passes those inputs between a set of layers. And those layers allow for more abstract pattern processing between those different inputs. And between those layers are weights. And then those weights determine how much one input or layer impacts the next. And we can think of those weights as the model's understanding of those inputs and their relationships to each other and the possible outputs. These relationships and these weights are learned during training from a training data set. And this means that the model's entire understanding of the domain it comes from the quality of the data set that it is trained on. And then at the end of this network, the different outcomes, so for example, rain or no rain, are valued in terms of how much they are activated by that network, which we can interpret as a probability of that outcome being the correct one. Next slide, please. So one way in which neural networks are used is as part of transformer embeddings, which are part of the basis of LLMs. So embeddings are a way of representing words as really, really large vectors that have thousands of dimensions. And these dimensions are really abstract, but we can kind of imagine, for example, that two of these dimensions are nationality and geographic size. So you can see in the graphic on the right that Ottawa is the same distance from Canada that Madrid is from Spain. And that is because they both have that same shift in geographical resolution from capital to country, but the nationality of Ottawa to Canada and Madrid to Spain is the same. But likewise, you could also compare Canada to Spain and Ottawa to Madrid as being this the same geographic resolution, but only shifting the nationality. And so these embeddings are pre-trained and they have some amount of context with them, such as, a riverbank is different from a bank that you put your money in. And the extent to which surrounding words influence the meaning of a given word is drawn from a process called attention that assigns a probability as to how important one word is to another in the sentence. In LLMs, these embeddings are fed through many layers of neural network that refine the understanding of the text using attention, from words that surround each other to sentences that surround each other to paragraphs, to form a complete understanding of the entire text. And this understanding is what then allows those LLMs to make a probabilistic prediction in order to generate text. And so I'll hand it over to Mo to explain more about that.
Where we are in this evolutionary timeline of thinking machines that Amber painted for us is what we're all been hearing in industry, which is LLMs. And here is a very simplified visual of the mechanics of models and how they work. So initially, we start off with a sentence or a prompt that you'd normally pass into your chat GPTs and Claudes and other model providers. And what essentially happens is pretty much what Amber painted in a really nice way, which is it gets passed into a bunch of computations that come out with the most likely word that is to continue that sentence. And once that initial pass is done, it is a basic iteration of that until there is a stop sequence. So the reason we kind of wanted to show this visual specifically is because, you know, LLMs have kind of ballooned or exploded into their own industry, which is agents, co-pilots, chatbots, so many other things. And you hear nowadays about research and prompt engineering and all these different nuances. But what essentially they are is at the core, or they're wrappers around a very similar core, which is the prediction of a sequence of words that go together. And what information you pass in and what that starting information is how you get the model to print out or predict the correct completion of the sentence or of the chain of thought that you are looking for. And that has obviously become almost a full-time job and a line of experience and subject matter expertise. And there's a lot of different elements that we'll be covering in future slides. But yeah, essentially this is, you know, when we talk about all this AI and where we are right now with it, this is essentially what's going on and deep under all the hoods and the covers and the wraps. So
yeah, I call it fancy autocomplete. So with that, we're gonna take a quick little pause here to you know, sort of poll everyone, like what are the decisions you're trying to make? So the probabilistic nature of AI, you know, enables you to answer questions, usually questions that involve a lot of data points. So let's take a couple of seconds here, you know, a minute, for everyone to scan that QR code, and then we'll show sort of what the crowd is thinking in terms of how to use the probabilistic nature of these models. All right, so we got a couple of things coming in here. So contract negotiations, predict matter outcome. Okay, that makes sense. Negotiate. I see gold. I'm very curious what gold is. Okay. Drafting, life sciences, laterals, early warning. Okay, pricing, BD. Yeah, so this mostly tracks with sort of the buckets, right, that we've been seeing. At least, of course, within the context of legal tech. If we look at sort of the love story so far, all of those, at least most of those responses fit in the categories that we've been seeing, which is, you know, workflow streamlining, e-discovery and litigation, right? Like the relativities of the world. They're using the probabilistic nature of these models to figure out what evidence is actually relevant for a case. Research and intelligence, right? Like the Lagoras and whatnot, looking at all of the research and history, doing comparative analysis, all that is using some sort of probability to figure out what is actually relevant for the research. Knowledge and content automation, like the Centauris of the world, right? Taking all that internal knowledge of the firm, figuring out which sort of documents are relevant or drafts to propose, right? That's all using probability to predict how you want to create the next set of documents. And then, of course, you know, contract review, of which there's a lot of options nowadays, but similar idea, using the probabilistic nature of these models to take forms and predict what the next contract with the next form will look like. As I love to say, it is a very fancy autocomplete, right? Now, we know, at least most people in the space know that, you know, most of these tools are powered by these, at least LLMs, right? But even with all of that, you know, in order to have a proper outcome, what matters is the data that's going in, right? So these are some of the questions, the other high level questions that we've identified, right? Such as, you know, what industries should our firm prioritize, right? Like, how are we going to expand our clientele? Partnerships that we're going to make, events that we're going to throw, you know, what is it that we should be looking at to grow the firm's presence? A lot of people in knowledge management and innovation here. I've talked to Oz a ton about this, which is, well, what if we used AI to identify which AI tools we should use? I said, that's a very meta concept, but it's a very good application of AI, right? Use the probabilistic nature of it to figure out which models you should use, right? Which tooling you should use. And then, of course, you know, anything around deals, litigation, the actual operations of a firm, These are all great use cases for AI. But like I said, it's all about sort of the data that you feed into it. So we're going to touch on that next. But before that, I just want to get a quick pulse of the room in terms of how much you trust these systems already. I think what's interesting is we're already at a point where no one's not using it at all, right? And I think that's a really clear indicator that a technological shift is taking form, right? It's becoming a commodity, it's becoming commonplace. And we're seeing it, starting to shift more towards the right. So this tracks with what we've been seeing and what we predict is going to continue to happen. But like I alluded before, it's all about the data. So let me go back to the presentation here. Let's talk about what it means to put in garbage versus gold.
All probabilistic AI is built on training data and is also dependent on the inputs that you give it. And ChatGPT and other, very accessible models are trained on a really vast, diverse set of data, but are often not trained on the most expert, proprietary, and specific information that we might want it to use in order to accomplish a certain task. And if we want probabilistic AI to understand and generate according to our standards, we first need to show it examples of our standards. And this requires a shift in how we think about and prepare our data, especially for third-party vendors with LLMs, to identify and provide data that gives examples of what we want AI to do, gives context of the areas that we want AI to understand, and is combined with a communication about what is essential in understanding that task, which is domain expertise, which is something that everyone can really provide for a given task. So for example, to go back to our predicting rain example, if they use air pressure and temperature and humidity as features in order to predict rain, those things didn't come out of nowhere. They came from a domain understanding about what sort of conditions impact whether or not it's going to rain. If they fed it, how the Yankees are doing and how many flights came out of LaGuardia today, it would not make any sense. And so that's really what domain experts can provide, is both the actual data, examples of, for example, if you want AI to draft a letter, examples of what good letter writing looks like, but then also an understanding of what exactly is it that creates a good letter, and how do you find that in the generated text. So this shift is critical because if you work with generic data, you will get generic outputs, whereas the first to develop AI using specific and relevant data will be the first to profit from it.
With that, a big piece of this is buying versus building. Oz and I have talked about it's actually renting, because you're not buying. Well, oftentimes you're not buying anymore. It's more so renting the solution. So I'll let Mo touch on this.
Yeah, that's a very important differentiator to note, because I would love to go around and say we're buying AWS, but we're just renting some of their server space, unfortunately. But yeah, so this is kind of, so far we've covered a lot of different aspects of what this technology actually is and how it's kind of different from what we do. And now is when we take that information and kind of go, all right, this is hitting a little close to home now. It's coming into your places of work, and there's a lot of considerations of how it can come in and how it can be adopted that need to be taken into account, so that an adoption of this technology in this space is done as safely as possible, given the nature of the operations happening in the industry. So what I wanted to touch on here briefly is the concept of buying versus building. So at a high level, it's, are you investing in this, or are you still experimenting with this? So when we look at the buying piece, there's a couple of ways for buying to kind of come out of a business's operations, which is you can either pull an off-the-shelf model, you can use the Chat GPTs, or you can use the Claudes and Grok and many other model and inference providers that exist out there and coming out almost every single day. Or there's a lot of smaller companies out there that are looking for design partnerships, and you can sign design partnerships, work with a smaller company that is dedicated to only you, to build out a product with you. You can also go for a white labeled solution. So ChatGPT Enterprise, Claude Enterprise, those like high dollars per month subscriptions that give you not only the data security, but also the availability of one of the large model providers. Or there's an API integration. So APIs being the model and the inferencing kind of exists elsewhere. You build a little product around it, and you're just using the AI model as a third party vendor from a third party vendor. So with the buying approach, there's pros and cons. On the pro side, it's very low commitment. You're not spending relatively, you're not really spending an obscene amounts of money. The time frame is 100% in your control, whether it's an off-the-shelf or a white labeled solution or a design partnership. In many of those contracts or many of those negotiations or relationships, you're the one with the leverage because to them you're a customer, and that allows you to set your own time frame, set your own terms, and go at the pace that you're comfortable going. At the same time, there's another side of the coin, which are the cons, and what those kind of look like is there isn't that much room for customization. So if the model kind of acts a certain way or behaves a certain way, a very important point that Amber touched on was gold in, gold out, garbage in, garbage out. If you're working with a company that is building a general purpose model or a model for not just your firm, but many, many other firms, and it's hoping to build a market out of it, you might not get the accuracy of the responses that you're hoping of getting. As well, the other point is if you're going with something like an API approach, it does not necessarily offset the full need for overhead. There will still need to be points of contact, part-time contractors, full-time people who are able to understand some of the services like the APIs that are given to your firm and are able to build something around it that you can use. Another part of it, given the nature of the data in this industry, obviously we generally speaking across enterprise software, but very, very specifically in the legal world, data concerns and data security concerns and InfoSec is a very, very big aspect of the decision-making process for working with people like third-party vendors. But then also when you start relying on technology a lot, especially ones that are deployed in cloud services, SLAs become a thing. So the outages are a very, very big consideration. And while a lot of technical companies put a lot of resources to making sure that outages and downtime doesn't necessarily happen, that is still a reality of products that are worked on. So yeah, that's kind of the overlay of the buying side. Now shifting over on the building side, what building essentially looks like is hiring an in-house AI team, which is on a very, very small scale, what Meta's doing right now, but minus the tens of billions of dollars, leveraging a lot of open source frameworks, implementing AI frameworks that are available out there, and most importantly, taking readily made models and pulling them in-house. So what that kind of resembles, or what we can kind of say on the technical side of AI is, on a very slight tangent, there has been a very large discussion or debate rather in the AI world, which is everyone's working towards what they call AGI, which is artificial general intelligence. Where the debate is that going to happen in a closed source environment, meaning within the labs of OpenAI, within the labs of xAI, within the labs of Anthropic, or is it going to be a community-led effort? So there's a lot of these big companies that are coming out right now that are either that are picking a side. So they're either closing all their models and only saying, here's an API, you can pay a bunch of money to use it, but you're not going to see what it actually looks like. And then you have other providers that are like, you can download the models, host them on your own servers if you want to. Here's what they look like, and here's the data that we use to train them. And there's, bringing it back to the main topic, there's a point of leverage or an opportunity to take advantage here by taking those models that are already made, pulling them in-house, and building what you need around them. And there's a lot of considerations here, obviously, being, full customization. You get control over what gets implemented and when it gets implemented. You set your own timelines. You know exactly what needs to get done to meet those. Most importantly, the data does not leave your firm, which is a very great thing on the security side. The cons of building is there's a longer time to launch, because when you work with a vendor, for example, they have already either raised VC money, have hired a team. You need to do that yourself. There is a very big investment that you're going to have to do in the tech side of things, bringing in tech talent to build a team like this. And then from a risk perspective, it's a very long-term investment with no absolute guarantee of a result. So it's risky, but it puts as much things in your control as possible. And then comparing the two in the next slide, there's one important note. So obviously, this is a very subjective matter. There's no right or wrong way, whether you want to buy or build. It depends on your budget, your risk thresholds, your curiosity, really. But the main considerations to take into consideration is this is not really a binary issue. When we talk about buying versus building, there's no, you either buy the entire thing or build the entire thing. You can buy the model and then build the software around it, or you can buy the design partnership that gives you an API for the product, and you can click it into a dashboard or a console or anything that you're using to already view all of your data. So there's a mix and match that you can do. And the one rule of thumb that we've kind of seen here is, with a lot of the smaller AI companies as well, this is something that might be taken taken into the legal industry as well. The LLM improvements and the training of models at the size of GPTs and Claudes and the Llama models from Meta, for example, is something that normally costs tens, if not hundreds of millions of dollars. So what we generally like to say is you leave the model improvements to the companies that are spending or can spend this amount of money, and you put all your resources into seeing how you can build on top of that. So that's usually a nice balance that we've found, at least. But then the main point being, kind of being the two levers that exist in making that decision, which is risk and then investment, or how much money are we willing to put into this? Because if you're pulling a model in-house, for example, the investment is going to need to be very big into architecture, talent, overhead. But then most importantly, in the points that I've mentioned in the previous slides, data. It's, do you trust a vendor with your data? And that's a very big vetting process to take into consideration as well. Yeah, so focusing on one specific piece, risk threshold is a very big consideration to take when it comes to making these types of decisions. You're taking financial and time risks to do either. So at the end of the day, what are some of the risks that exist in the nuances of working with these models that could help you make that decision? There's one that we kind of focused on here, and then just a general point. Pat, if you can go to the next slide. There we go. Awesome. So this is where I kind of come clean and say I'm not really a lawyer, but I do watch lawyer shows. I am a fan of them. So there is Suits. When we were talking about what points we want to kind of make here, this specific line that you see in the image here came to my mind, and it was basically, the rules dictate that you must be precise as the law is a precise endeavor. And I took that, and I was watching that line, and I recalled that line in the middle of debugging a bunch of model things that we were doing here at Abstract. And I came out with what you see in bold here on this slide, which is, lawyers are already excellent prompt engineers. You all know exactly how to talk to models, because what you put in and how you word your sentences matter in the output of the model itself. One of the biggest examples of these is essentially confirmation bias, which is models nowadays tend to be people pleasers. So they want to agree with you. They've been fine-tuned and trained to agree with you. And what that leads to is if you're heading towards a direction of a potentially wrong decision, uh, it does not currently contain the reasoning capabilities to correct you on that. It will need some time or need some wording to actually go, oh, wait, no, let's consider this alternative approach. So these are two examples of prompts that we have here. And they sound the same. So reading them out, I'm a lawyer at an AmLaw 200 firm. My lead is a startup with not a lot of money, but need legal counsel. Should I help them? Versus the same sentence, but why should I not help them? That change alone, the two extra words that we put in the second prompt, can make the model go from making a decision on whether or not you should be helping them to just finding a reason on why you should not be helping them. We have found this in so many different scenarios in our use cases at Abstract where, you know, multimodal models or applications came out recently, which is giving the model a capability to understand images. And if you take a baby next to an NBA player and you say, look at this image, now tell me why the baby is taller, because I believe the baby's taller. It will find reasons to tell you why the baby's taller. And it's obviously wrong, right? So that's just one of the nuances where this is kind of a new ball game we're sort of playing here with this new technology where it's not a single button or an input form and you click on it and it either works or it doesn't. These models can work, but the failures in these models are semantic. They're not necessarily functional and as clear. So yeah, that being said, lawyers are great prompt engineers. So,
and that's where we sort of tie it off with, okay, do we commit now or do we wait, right? With everything that's going on. And of course, our opinion is we commit now, and we start accelerating our ability of, fine tuning the combination of working with external vendors or models, building in-house, right? This is all going on as we speak. And so, so the main takeaways here, and then we'll go into questions, is, of course, number one is obvious. AI is reshaping how we work. It's rewriting our processes, priorities, how we think, right, about things. Similar to how I always say the calculator, right? Change the way we did arithmetic. Number two, probabilistic AI is not limited to LLMs, right? As Amber showed in the RAIN example, a classifier is another form of a probabilistic AI model that is much more, sort of well suited for answering the question of whether it's going to rain or not. A classifier costs a lot less to run to make that prediction. And so the solution isn't necessarily throwing LLMs at every problem that your firm may have. And so the way you are able to, ensure that you're using the right approach is hiring in-house talent to vet that, or, work with vendors that understand the differences between the models and approaches and figure out what's the most efficient and effective way, right, of applying. And the last piece is data directs output. And, good data, good processes in equal good data, good processes out. We touched on a couple of examples here, but really ensuring that you're aligning your stakeholders internally at the law firm to be able to sanitize that data for the vendor or your in-house team is really important. Also, working with the vendor or your in-house team to label data properly is important. I think there's, my last thing here is a shift needed in how we think about this, right? Data, of course, is very, very special, very important to a law firm. It's why, many law firms still have on-premise servers, right? But being able to work with your team in-house or your vendor to ensure that the security standards are met, that's going to be the name of the game, because without leveraging that data, you're not really going to get anything out of these models. So I will pause there and open this up to questions. I know we have about 15 minutes here. First from Mary, how does probabilistic AI handle unexpected or unprecedented behavior? For handling unexpected or unprecedented behavior is sort of tied to the context, right? It's like, what are we looking at? So quick shifts in government policy, for example. The first part is just, how is it understanding that there are quick shifts in the government? So first you have to look at sort of the data source, right? That it's monitoring. I guess in our case, we are looking at shifts in government policy. And the way we do that is we had to build data pipelines across all these government entities to figure out what's going on, right? So we are monitoring changes every day. But aside from that, the model needs to understand updated context around how that shift may impact the client, right? Or how it may impact the company. So if there's a new tariff, for example, if there's a new tariff that comes out, is that tariff relevant to these two clients versus this one, or is it relevant to all of them, right? And I think, Mo, actually this ties into why we don't believe in updating the model itself, but rather updating the knowledge around the model, because it's a lot more efficient.
I would just say, as a quick point to add to that, is since models have come out over the past couple of years now, prompt engineering has been a very big thing that has come out, and I'm sure it's been heard of across many different verticals and industries. Specifically with prompt engineering, what matters the most is it's giving the model as much information to make a decision. And with, as Pat mentioned, there's 20% of the changes are essentially made by retraining the model. But 80% of it is how you prompt it and what information or context you give it to make those decisions and insights for you. So,
yeah, and that actually ties into the question Ron asked, which is so oftentimes humans make mistakes, right? Or experts disagree, right? We're not perfect. So in the case where experts do not agree, how does that affect the probabilistic determinations? Yeah, I would say this is probably like a sort of tied to how we're training what is right versus wrong, which Amber, sort of dovetails into the things that you brought up about the weights and whatnot, right? Like as a whole, the models that we use today were trained on some sort of data set, right? And so whatever the expert said in that data set is what that model is typically going to trend towards agreeing towards, right? So in the case of disagreement, our understanding is like typically that leans towards wherever there is more agreement, right? But Mo, Amber, I don't know if there's anything else.
Well, let me put a little bit more of a spin on this, because I'm reminded of a decade ago when I was doing focus group interviews in law firms for knowledge management, and many of the skills folks on this call will relate to this, where I asked, and this was not a firm that was best known for emerging company practice, and I interviewed the associate, said, do you have a set of documents for emerging companies? And without irony, they said, yes, one set per partner, right? And I don't, some of the folks on this, in the firms in this call will have harmonized that, but, I think that's a pretty common problem. And I don't know that there's an answer. I'd love for others who are more on the knowledge management side to help think that through, because I don't hear much discussion of that if you're trying to convey and capture the firm's own expertise, that it may not be uniform.
I think, Mo, part of this also ties into confirmation bias, right? Sort of, if there is disagreement, is encouraging surfacing the fact that there is disagreement, right?
Yeah, I think
confirming a path. Yeah,
exactly. Well, one very big thing that's happening right now, popping up a lot in the specific tools, is giving models personalities. And sometimes one of the things that happen is there was a Google model that recently came out, an agent that was built around that, that just had so much of a personality and an attitude that it kept disagreeing with everything. So it very much, I think, depends on, I think what it falls back on is essentially like Amber's point of gold in, gold out, garbage in, garbage out. Amber, I don't know if there's any other points you wanted to add there.
What we would probably say about this is that if we have a situation where experts are disagreeing and disagreeing by a lot, we would say that it's really difficult for the model to generalize because there's not a specific set of conditions on which it can really like rely on those in order to make probabilistic recommendations. The nice thing about language is that we can present it in such a way that if we want to say, hey, like there might be these different but related ways that are generally similar and accomplish the same goal, but they don't literally have the same advice every single time. That's something that a model might be able to do if through prompting engineering and explaining sort of the conditions of how this data comes about.
And that actually dovetails into the other question, Ron, that you asked, which is, sort of recommendations on prompting given the minor word changes and whatnot. So Mo, Amber, I'm sure you guys have resources. I don't know what are the top couple of recommendations, research papers, areas that sort of help with that.
There's one that comes to mind that I can share, because confirmation bias surprisingly is just one of those things like hallucinations that have not been totally addressed even in the LLM and like AI community specifically. One of the things that I found recently, it's a paper that I've been meaning to dive into, is essentially what's called a mixture of experts architecture. So you give a model an answer, but what's really happening behind the scenes is you're not giving one model the answer, you're giving a collection of agents the answer, and they basically debate it and then give you a final answer. Obviously, latency, it will take a little bit longer, but yeah, that's one of the many approaches, unique approaches specifically, that I've seen in people addressing those nuances in prompting. Other thing that comes to mind would be, I think just a human in the loop review that's basically just, reading the answer before it gets passed in, just making sure you're not letting it lean one way or the other. Obviously, it's very manual, but we are still very early in this tech, so I'm sure I'm keeping an eye out, but I'm sure that there's going to be some new tools that come out that'll help us do that. So,
are there clear records and representations as to the provenance and use rights of the data sets, right, used to train these models, particularly where cross-border data transfer or localization restrictions may apply? So high level, my opinion is that we are going to see a lot of these sort of standardizations as to how the data is handled and sandbox and whatnot baked into a standard like SOC 2, right? So SOC 2 compliance is standard for working with any enterprise. We think it's just going to be part of what's included in that, maybe as an addendum. Right now, in our experience, we work with large corporations, their in-house legal teams, and then also we work with AmLaw 200 firms. They have a flavor of AI addendums that they've made up, for lack of a better word, for now. There's some similarities across all of them, but because it's so early, it's still very much in flux. So that's sort of where we see that trend going. And then Chris asks a question. Let's see. Are you aware of current in market applications that give probabilistic answers and their likelihood as opposed to a definitive single answer? Chris, I don't know if you're here. I wonder if you could maybe give a little bit more color to that.
Yeah, I was just hoping to see if you're aware of any programs, applications, whatever, that give you, as opposed to a single answer, right? You say, hey, I'm looking to find this about this regulation. It might give you 3 answers and say there's an 80% likelihood it's this, there's a 50% likelihood it's this, etc.
I think Mo has some thoughts on that.
yeah, that's actually that's a whole can of worms. So it's funny because I was having conversations with a couple of folks like a year or two ago, that was about this. So one of the things, Google recently, like last month, came out with something called AI mode, and it essentially like reads their indexes of web pages and gives you one single answer. Um, and what was funny about that is I was having a conversation with someone working at Google a couple of years ago, one of the leads of what eventually came out to be AI mode, and the main thing that we agreed on was that having any sort of web browser agent respond with one single answer is as if you're doing a Google search, and no matter what there is out there, going with the first response only. So there should be a change in UX and UI that allows people to look at the basically the equivalent of like page one, page two, page three, page four, and like here's them ranked based off of relevance. Uh, so far, personally, I have not seen anything that hasn't been like something built in house, unfortunately. But definitely something I'm on the side pushing for. So I hope we start seeing them come out in a couple of products.
Yeah, what I would say is, I mean, we're happy to nerd out separately about this topic. But to the extent I can share, that's part of the logic that we've been building out internally as we assess regulatory codes and whatnot, because it's not always binary, right? Oftentimes it's not. So it's like a prioritization list to it. So with that, let's see, last one. So Nick, as model cost comes down, allowing us to repeat a task/instruction, do you think the difference between probabilistic and deterministic is eroded? For example, if we reduce the risk of probability-led errors by repeating the task enough to eliminate the low but not impossible probability bad outcomes. Okay. This is
Sorry, that question sounded less complicated when I wrote it than when it was said out loud. But Mo, I think you kind of half answered it earlier in the way you were talking about the way some of the agents are working, and they're actually repeating this instruction, they're referring to each other, they're cross-checking, and all of that is in order to, you know, compound their confidence in the answer so that the probability is sort of a bit less wild. But I guess if you really follow that through, the things that there is one singular right answer, if you ask the question enough times and roll the dice enough times, then you get to the right answer rather than being at the mercy of probabilities. So I think you kind of answered the question before we got around to it.
Yeah, I think that's actually, funnily enough, that's sort of the main focus of pretty much the entire AI community nowadays, where it's working towards not specifically eroding the difference between probabilistic and deterministic, but specifically focusing on reasoning, chain of thought, allowing a model to not only give you an answer but explain why it came to that answer, is a very big aspect of new frontier models and large language like LLMs that have been coming out recently. And the one big trend that has kind of been following that as well is deep research. So OpenAI yesterday, for example, came out with a browser agent that's capable of doing deep research. So initially, what that technically means is you can do large or very long browser tasks, but what that truly means is kind of letting it bumble less and just actually get to where you need to go. So whether that's a true erosion of probabilistic and deterministic, maybe Amber has a take on this that I might not, but yeah, it is sort of the guardrails are sort of being put for a lot of these models as we kind of progress. So
Yeah, definitely. And I would just add to that you know, deterministic by nature, it has no awareness of alternatives. It doesn't necessarily mean that the alternatives are such low probability that they don't come up often. So, you know, and as long as it is a probabilistic system of considering other outputs or like potential results, then it won't be deterministic.
Yeah, I know we have 2 minutes left here, so just quickly touch on this last question from Jennifer. You're absolutely right, where, you know, if you're not providing proper training data and whatnot, there may be issues in sort of its outcomes, right? But This is also actually another pro of like working with a vendor. For example, like in contracting, like Harvey or Legora, they have inferences that they've already modeled out from other law firms, right? So now they have gold data that they've created by working with multiple law firms. And so that's what's going to happen with these vendors as they work with more firms, is that they have second order gold data that they got as inference from the training data from their clients, right? So that's going to be something that's going to become common. And I agree, Mary, I think we're going to see a lot more visualization. So we really appreciate all the questions today. We're based here, as you can see, Mo's background. I'm actually in the same office. We're in Dumbo, New York. So if anyone wants to grab coffee, nerd out more, let us know. But really appreciate the questions, and thank you, Oz, for hosting us here.
Absolutely. We would love to get your feedback, people. We have a few more. We want to know whether to continue after we're going to take a break after ILTA for the remainder of August. But some people suggest that they want to hear more in September. So if you could, in the feedback, let us know what topics you want to hear about. Thank you very much for the guys from Abstract. Next week, we're going to have an interesting collaboration between Megan and Scott. They're going to talk about some of the things that you need to get ready for the cloud in the era of AI and agent and knowledge and all those things. So if you have any questions ahead of time, please feel free to include them in your feedback. And we'll see you next Friday at 11. Thank you very much, Pat and the team, Amber and Mo. And thank you for all the active audience participation.